At highway speeds, slamming your brakes forces your vehicle to convert thousands of pounds of kinetic energy into violent thermal energy. In mere seconds, your steel brake rotors can spike past 1,000 degrees Fahrenheit. The absolute only thing executing this energy transfer to stop your 2-ton machine are 4 hand-sized blocks of friction material. But their chemical makeup dictates exactly how your car behaves. Organic brake pads, technically classified as non-asbestos organic, or NAO, are manufactured using a tightly compressed matrix of glass fibers, Kevlar, carbon, rubber, and specialized high-temperature binding resins. These are the standard, factory-equipped choice for roughly 80% of all compact cars, minivans, and daily commuter vehicles on the road today. Why do engineers rely on such inherently soft materials? The primary engineering goal is the absolute reduction of NVH, which stands for noise, vibration, and harshness. Because the friction material is physically forgiving, organic pads conform microscopically to the surface of the brake rotor. This creates a deeply predictable, incredibly smooth pedal feel, while actively dampening the harmonic vibrations that cause high-pitched brake squeal. However, there is a severe limitation you must be warned about: catastrophic brake fade under extreme stress. If you use organic pads for heavy towing or aggressive downhill driving, the thermal threshold is quickly breached. The synthetic binding resins inside the pad will literally boil and vaporize, creating a highly pressurized layer of gas between the pad and the rotor. Your brake pedal will go terrifyingly soft, and the vehicle will stop decelerating. When compared directly to metallic alternatives, organic pads are vastly quieter and produce far less visible wheel dust, but they possess the shortest overall lifespan and the lowest thermal capacity. Stepping into the heavy-duty sector, we find semi-metallic brake pads. Depending on the exact metallurgical formula, these pads consist of 30 to 70% raw metal, specifically steel, wool, iron powder, and copper wire sintered together under massive pressure with graphite lubricants and inorganic friction modifiers. You will see these equipped on heavy-duty pickup trucks, large towing SUVs, police interceptors, and high-performance track-day sports cars. The reason metal is introduced in such massive quantities is all about manipulating thermodynamics. Metal is a highly efficient conductor of heat. During repeated, aggressive braking, the metallic elements within the pad act as a functional heat sink. They actively absorb extreme temperatures and channel that heat away from the contact patch. This allows the braking system to maintain a massive coefficient of friction even when the rotors are glowing red. The critical warning for daily drivers, however, is the side effect of abrasive, metal-on-metal friction. Semi-metallic pads will generate a heavy blanket of thick, highly corrosive iron dust that will permanently pit your alloy wheels if left unwashed. Furthermore, on freezing winter mornings, before the metallic compounds can heat up and expand, they are notorious for grinding and squealing loudly. In a direct comparison, semi-metallic pads will outbrake and outlast organic pads in extreme heat, but they are the loudest, dirtiest option, and they will aggressively shave down your cast iron brake rotors over time. Next, we move to the premium tier of street performance: ceramic brake pads. These are highly advanced composite blocks, built from dense, killine-fired ceramic fibers engineered to withstand immense structural stress, interlaced with soft, non-ferrous threads, like copper or brass, to assist with heat transfer. This is the ultimate aftermarket upgrade for luxury sedans, premium daily drivers, and automotive enthusiasts who demand a pristine, absolutely silent driving experience. Why utilize expensive ceramic technology? The answer lies in acoustic frequency shifting and tribology. When ceramic fibers scrape against a spinning steel rotor, friction is still generated. But the ceramic material alters the acoustic frequency of that friction, pushing it up into the ultrasonic range. It makes a sound, but it is entirely outside the frequency range of human hearing, resulting in dead silence in the cabin. Furthermore, ceramic pads use adherent friction, meaning they transfer a microscopic film of pad material onto the rotor, stopping the pad from gouging the metal. The downside you must consider is how they handle extreme heat. While ceramic itself can survive high temperatures, it is a thermal insulator, not a conductor. If you take ceramic pads to a racetrack, they will not absorb the heat. Instead, they will force all that extreme temperature directly into the brake rotor and caliper, which can easily boil your hydraulic brake fluid. Compared to the rest of the market, ceramic pads are the ultimate Goldilocks zone for the street. They outlast organic pads, they are infinitely cleaner and quieter than semi-metallics, but they lack the heavy-duty thermal bite required for towing or racing. At the uncompromising pinnacle of motorsport engineering, we have carbon ceramic brake pads. This is not a simple top coat. This is an aerospace-grade, super lightweight composite matrix manufactured by baking raw carbon fiber and silicon carbide in pressurized ovens for several weeks. You will exclusively find these equipped on multi-million-dollar hypercars, Le Mans endurance prototypes, and the absolute highest tier of track-focused supercars. The engineering philosophy here is singularly focused on extreme, repeatable, fade-free violence. A carbon ceramic braking system can operate flawlessly at temperatures exceeding 2,000 degrees Fahrenheit without a single percentage drop in friction. Simultaneously, the material is astonishingly lightweight. This drastically reduces the unsprung rotational mass at all four corners of the vehicle, allowing the suspension to react faster and the steering to feel razor-sharp. But if you plan to use this exotic technology for casual city driving, you face a serious safety warning regarding cold bite. Carbon ceramic compounds require immense heat to activate their friction properties. When the brakes are completely cold, like when you back out of your garage in the morning, the brake pedal will feel like a block of wood, and the stopping distance will be dangerously long. They must be aggressively warmed up on a track to function as intended. When compared to everything else, carbon ceramics completely rewrite the rules of thermal dynamics and weight savings, but a single replacement set of these pads and rotors will easily cost as much as a brand new economy car. Regardless of the advanced chemistry and engineering clamped around your wheels, your braking system is the absolute final safety barrier between you and a catastrophic collision. Always perform routine inspections on your pad thickness. Never ignore the warning screeches of a wear indicator. Replace your components according strictly to factory service intervals, and subscribe to the channel to discover the hidden mechanical reality of how your vehicle truly operates next week.